All right, so welcome to CS 891. Nice to see some familiar faces from last semester. My name's Doug Schmidt, and I'll be giving you an overview of the class today, and I'll also be talking about the programming assignment and giving you pointers on where you can find more information we'll be covering in the class. So what we'll do today is kind of give an overview of the course philosophy, talk about the course contents, how the lecture material will be structured. I'll talk a bit about the first assignment, which is available, and give you an overview of where you can find the tools you'll need in order to set up the assignment and do it effectively. And also I'll talk a little bit about accessing Android and Java source code. So let's go ahead and get started with the course philosophy. So you may or may not know there's a growing demand for people who have expertise in the topic of concurrent programming. And this includes a range of different computing platforms, cloud computing, desktops, laptops, mobile devices, and so on. And a lot of this is driven by various factors having to do with an increasing amount of cores available on modern multiprocessors, the availability of mass storage, which means we have lots of things to process, the ubiquitous network connectivity, which means we have clients connecting to lots of servers, and of course the fact that almost all modern computer platforms, hardware and software, have support for concurrent and parallel processing. If you take a look at the link on this page, you'll get a sense of one of the interesting trends that's driving the emphasis on concurrency, and that is essentially what's called the end of Moore's law as a means to increase computer processing speed. We'll talk a bit more about this later, but in a nutshell, for about the past 10 years or so, computers really haven't increased very much in terms of their processing capacity. They're running about 3 gigahertz per second at this point. In contrast, the number of cores available to process things in parallel has in fact increased. And that, of course, has driven people to look for ways to take advantage of all that processing hardware. And so concurrency and knowledge of parallel processing are some of the key themes there. Many, many years ago, back when I first started learning about these topics, 25, 30 years ago, we didn't have all this hardware at our disposal. So in those days, you were forced to learn about concurrent processing primarily by reading papers and analyzing algorithms like Decker's algorithm or deadlock detection algorithms. And it honestly wasn't really very enlightening. You'd read all this stuff, but you'd have no easy way of being able to figure out how to actually try it in practice. So my experience then was I didn't really remember much if I just read about it in the abstract. So what we'll be doing in this course is actually getting a chance to read and write concurrent code, debug concurrent code, learn how to design concurrent code, and so on. And we'll be doing this with a couple of different programming paradigms. We'll be using, of course, object-oriented programming and design, which is at the core of a lot of Java. And we'll also be talking a bit about some of the newer paradigms, such as functional programming. And I'll be giving you an overview a little bit later about some of the new features that have come with Java 8 and Java 9, which came out last fall, which make it much different and in many ways easier to write concurrent programs. So we'll be doing a lot of hands-on practice, getting a chance to apply these things to real code. So let's talk a bit about what the course will cover. We'll be covering the foundational Java and Android concurrency mechanisms. And I'll talk more about what the foundational pieces mean. We'll be talking about Java 8 programming language features a bit. Although this class is not really focusing on that, I'll give you resources you can go to learn more about it. And we'll be talking about some of the basic concurrency mechanisms. As you'll see later, there's a lot of stuff in Java related to concurrent programming, and we're going to focus on a piece of it. We'll also talk about some of the features that Android has for concurrency, as well as some communication mechanisms for talking between processes on an Android device. That'll come a little bit later in the semester. If we have some time, we'll talk about how to communicate from mobile devices to cloud services through various techniques, including things like content providers and or various bound services. We may or may not get to some of that, depends on how much time we have. We may also, if we have time, talk about some of the patterns related to developing concurrent programs. That's also another interesting topic, depends again on how much time we have. And one of the things I'm assuming here is that people either have familiarity with or can quickly learn key things like Java and Java 8, Android, and Git. Some of these things are more important than others. Here's a good place to go. Here are 2 places that are worth going to learn about this stuff. We have a Coursera MOOC available on Android app development, so I recommend you you subscribe to that, it's free, and so you'll have access to all the material. And we also have some material from my last semester's course on concurrent programming, which has a totally different flavor from this course. And one of the things that the last semester's course starts out with is a whole set of lectures on Java and Java 8. So that might be a place to go if you're a little rusty and need to learn a bit more about how those technologies work. So how is the lecture material structured? Well, we're going to have these 4 main modules. The first part will be Java and Android threading. So we'll talk about Java threads and runnables and the executor framework. These are all ways of executing code concurrently. And we'll also talk a bit about Android concurrency frameworks called the Hammer framework, which stands for handlers, messages, and runnables, and the async task framework. Those are some things we'll talk about. We'll talk about the many different types of Java synchronization mechanisms, things like built-in monitor objects, things like semaphores and reentrant read-write locks and stamped locks and compare and set and all kinds of stuff, atomic integers, atomic booleans, atomic references, many things you'll find in the Java util concurrent package. We may talk about some of the Android features, things like bound services and the Android interface definition language, content providers, and so on. And I mentioned before, we'll talk about patterns. Chances are we're going to bounce around between these topics a bit, especially between the threading mechanisms and the synchronization mechanisms. And most of this bouncing around is driven by the need to make sure that the topics are covered before you do the programming assignments. So obviously, you want to be able to know what is in the assignment before you have to be responsible for coding it. One of the other things you'll find when you take a look at the course assignments is that I typically give you references to videos to watch on the topics that are covered in the assignment. We'll, of course, cover those topics in class, but if you want a little head start before we've covered them in class, you can go and watch the videos, and that'll give you a way to get up to speed quickly. Each of these modules is composed of a bunch of lessons. Each lesson is composed of parts. Each part is a single lecture. And these various lecture parts are going to be screencast, and then I'll put the video and the PDF versions of the slides up in my website, in which you can then also download and watch. One thing I'll talk about later, when you prepare for quizzes, a good thing to do is go back and look at the slides or watch the videos, and I'll talk a bit more about that later. Each part has some segments in it, and there'll be some discussion questions at the end of each part. And the idea here is that we'll get a chance for people to kind of think and interact as in a group to work through some of the problems. A lot of times the things we'll cover at the end of the discussion parts will be precursors for what will be covered on quizzes. So it's good to know that. Speaking of quizzes, there'll be a weekly quiz on material that's covered in the lectures. The quizzes and the finals are closed book and closed mobile device, so it's things you have to remember by watching the videos and thinking about what we cover. The first quiz will be on Wednesday, in other words, 2 days from now. It'll be very short, probably like 10 minutes long or so. I'll pass back and review the quizzes at the start of the next class. One of the nice things about having a somewhat smaller class than some of the other courses like CS201 or CS251, which has 80 students in it or so, is that we get a chance to interact a lot more, and I'll get to know everybody, and I'll pass the quizzes back at the beginning of class. We'll talk more about this later. It's very important to attend classes, and if you don't attend classes, in other words, if you don't come to get the quiz when I pass it back the next class, you get penalized. So make sure you show up to the class. Likewise, if you don't show up in class and just show up for the last 10 minutes for the quiz, there's a penalty too. So make sure you attend class. We'll talk more about that later. There'll be a final exam at the end that will be nominally going to cover anything in the course. Anything's fair game, though in practice it usually covers the stuff that we've covered in the past couple of weeks leading up to the end of the class, just because those are things we haven't probably covered on a quiz. Speaking of the final exam will be 9 to noon on Wednesday, April 25th, which I think is one of the first days of the final exam period, so you'll get that out of the way quickly. You can always find out, if you forget this, you can always take a look at the course website, which I'll show you, which has the final exam date and time posted there as well. The final exam will be in this room. So let's talk about the assignments and the assessments. So the programming assignments will be written in Java 8 using Android Studio. You're welcome to use whatever IDE you want, but your final submission has got to work with Android Studio 3.x. I recommend 3.1 or 3.0.1. Those are good. They have good support for Java 8. And you also need to be using Android 8.1, which is the Oreo release API version 27. I'll go over this more in just a second. One of the things you'll need to do is you'll need to make sure you have Java 8 installed. If you take a look at this link here, and of course all this stuff will be available on the website, so you don't have to copy it down. You can find out how to get the Java 8 code. It has a link to it. You'll have to install Java 8. You could also use Java 9 at this point as well, but unfortunately it doesn't work with Android Studio, so you'd be somewhat limited with how you could use it. Android Studio has a lot of really cool features that make it much easier to develop Android and Java code. There are wizards for creating apps. There's visual editors for creating GUIs. You can do manipulation of things with XML in order to describe the resources that control the layout and the display and visualization of your program, et cetera, et cetera, et cetera. There's a debugger. There's an emulator. You'll get to know some of this stuff in the class. We'll have some guest lectures by some of my colleagues who are experts at Android Studio, so they can answer your questions a little bit later as we get further into the course. You'll have to use the Oreo version of Android. You can read more about that here. It's the latest and greatest version, and it has lots of improvements and enhancements for various things. All the source code for the assignments and examples will be available on my GitHub repository, which you can get here. And you'll see if you go there that there's an assignment directory, and the first assignment's out. And there's also a video describing the first assignment. So I put that up this morning. If you take a look at the course website, you can figure out what's going on, and you can go to my YouTube playlist, and you can watch the video for the first assignment. I'll talk more about that in a second. In order to be able to use the code, in order to be able to do the programming assignments, you'll have to understand how to use GitLab and Git. Hopefully you've been exposed to this a little bit before. So Git is basically a way of doing source code control, and GitLab is a way to manage private repositories. Very important to use private repositories. And I use this for a couple reasons. We use GitLab and Git for a couple reasons. Number one, it makes it easy for me to put the assignments out and also to push enhancements to things. Every once in a while, there'll be bugs in the skeleton. In fact, if you were eager and got the skeleton from last night, please do a new pull, because I made an improvement this morning that makes it work better. So if you haven't done anything, the version that's there as a skeleton should work just fine. If you have already downloaded it, you have to do a git pull to get the new version. The second reason for using GitLab is it makes it real easy for me to review your code, and I'll talk more about that in a second. The assignments that you'll program here will give you a lot of hands-on experience with various Java and Android concurrency and communication mechanisms. We'll be using a really cool new assignment template for everything that we do in the class. It looks kind of like this. If you watch the video, you can see it run. It's basically what I call the Palantir simulator. Anybody here who knows anything about Lord of the Rings? The Palantir was a mystical seeing stone that you could use to communicate with beings in other parts of Middle-earth. And the way it works here, it's a great metaphor for concurrent resource management. And you can have a program where you can have some fixed number of Palantiri, say 4, and you can have some number of beings like hobbits and wizards and so on. And the beings take turns concurrently accessing the Palantiri. And the app is really cool because it'll visualize the gazing logic. And so it's real easy to tell whether your program works or not just by running it, and you'll see what it does. If it works, it'll be sensible. If it doesn't work, strange things will happen. It'll freeze, or you'll get various error reports and so on and so forth. So that's basically what we'll be doing as the driving application for everything. Using that as the driving application, then, you'll get a chance to play with lots of different concurrency models. You'll have a chance to play with 4 or 5 different types of threading models. You'll get a chance to play with half dozen or so different synchronization mechanisms, things like the executor framework, Java semaphores, monitor objects, concurrent hash maps, spin locks, all kinds of great stuff. And it'll be really fun, hopefully, and you'll get a chance to learn some interesting things in a way that is meaningful and not just like looking at text screens going whizzing by in a boring way. The topics may change a little bit, but this is probably what we're going to cover. The assignments, for those of you who've taken my classes before, this will be old hat. For those of you who haven't, this is the way it works. There'll be a multi-phase process for submitting and reviewing the code. And so first thing, you have to make sure you get things done on time. It's very important not to fall behind because you lose massive amounts of points, which you can read about here. What you'll do is you need to submit your code on the initial date, and I'll always send out a Google form that you need to fill in so I know where your repository ID is for Git and so on. And then I will take a look at your code, give you feedback, and then you have typically about a week to address my comments, and then you resubmit the revision for the actual grade. So the assignment's due, you submit the program, I give you a review, you get feedback, you get a chance to revise your program, you resubmit the program, and then it gets graded and you get the final grade. So in theory, at least, you should do very well, right? Because you're getting feedback. We will go over what I do after I do the initial review and screening of everybody's code. I have what I call the frequently made mistakes lecture, which we typically do in class, although sometimes if time gets tight, I'll make a video of it. But basically, I'll walk through all the problems I saw and people's solutions. So if you're keeping up with things, you should do very well. People sometimes, however, and fortunately it's typically a fraction of the people, will not follow the rules, and then they get themselves in trouble. So the first thing to do is don't abuse the system, right? You're getting the Cadillac of review processes here. You're getting high relevant, high information content feedback. But don't abuse that by turning in junk and then expect me to give you solutions. So if you don't make an initial effort to submit something that's sensible, like if it doesn't compile or it was clear you did a half-baked job, you get a 0 for the assignment. So with great power comes great responsibility. Don't try to abuse the system. Likewise, if you don't show up for class, you're also not going to get a grade. So it's important to be in class and to participate. So again, don't just think you can phone it in. And you can read all about this stuff here. Something else to mention, we often have problems with this. This is not a team project course. This is an individual course. So people who copy each other's code, that's against the honor code. I periodically have to turn people into the honor council for that. Don't do that. It causes everybody a lot of headache. I also review all your code, so it's typically pretty easy to tell when people have been copying each other's solutions. So be very careful with that. And I'm going to emphasize that multiple times because I've periodically had situations where we had honor council cases. People said, oh, I didn't realize I couldn't do this. I thought it was a team course. Well, it's not a team course, and we'll find various ways to make sure you understand that. This is what you'll be evaluated on. Your program has to work correctly. We'll talk more about that when we get into the assignment. That means it has to run and pass the various tests or produce the right result. That's really important. Counts for 40% of the grade. And then there's other things you'll get in terms of insightful programming, consistent programming style, appropriate comments. Make sure that you comment your code. That's another thing people typically lose points for where they don't really need to. Commenting is important, especially if it gets complicated. So you can learn more about that here as well. This is pretty much how we're going to weight the course. So there'll be quizzes. Quizzes are worth 40%. Programming assignments, they'll be worth 40%. The final exam will be worth 10%. And participation will also be worth 10%. And that's roughly 5% for attendance and 5% for in-class involvement. It's really important to be involved, right? It's not enough just to show up, but you actually have to get involved. And there's a lot of different ways you can get involved, and I'll talk about that. As I mentioned before, attendance also has ripple effects. So if you don't show up for class, you'll be losing points and other things. So showing up for class is important, but even more important is participating and getting involved. Sometimes people say, well, I showed up to all the classes, I did well, and why did I get a B? Well, it's probably because you just sat there and didn't really get involved. So you shouldn't expect to get an A, you can expect to pass, if you just show up and just sit there like a bump on a log. So make sure you get involved. Very important life skill to learn, and we'll incentivize people to do that. Let's talk a bit more about how to set things up. So if you go to the Android website, at this link, you'll see this picture, because I did a snapshot of this a day or so ago. And this is how you get Android Studio. Basically, what you'll do is download Android Studio, download and install the Java 8 JDK and JRE. Then you download and install the Android Studio 3.x. This is the 3.0.1, I think, is the latest stable version. There's also something called the Canary channel, and 3.1, I believe, is out in beta form there. You can use that if you want. Make sure you use the Oreo version, Android 8.1 API 27, which is this one right here. You probably could use the other ones, but it's just way easier for all of us if we all use the same version, because that way if problems occur, it's probably not because of the version. Also, make sure you create an Android emulator. I recommend using API 27. You probably can also get away with API 26. But again, if you get too far off the beaten track, when problems happen, the graders or myself won't have the same version that you do. So please try to stick with ones that are current. Something else that's important, if anybody here has an Intel machine, that's probably most of us. We're probably actually mostly suffering from the Spectre bug and the other bugs that people have. But if you have an Intel machine, the good news is that you can run an accelerator that will make the emulator work a lot faster when you run it. And I strongly recommend you apply this, because otherwise you'll discover that using the emulator is incredibly painful and very slow. So make sure you try to use the accelerator, the HAXM, as it's called, Hardware Accelerator Execution Manager. Try to make sure you install and use that. It'll really save you a lot of effort. Obviously, if you have an Android phone that's running recent versions of Android, you can use that too. You can get access. One of the cool things about Java and Android is the fact you can get access to the source code. So you can get access to the source code for Android for browsing at this link. You can also go and download it from this link. Worth doing. We'll cover some of the code in the class. You can also browse the Java 8 source code, and you can also download the Java 8 source code. I do this. I look at the code quite frequently. It's really quite interesting, especially with respect to concurrency and synchronization. A lot of cool stuff you can learn there. OK, so to summarize, you get out of the course what you put into it. No surprise there. The work depends on how much you like programming. Sometimes, especially for the first assignment, if you've done Java and threading before, it should be really easy. It'll get progressively harder. One of the real tricky things you'll discover is that debugging concurrent programs can be a bit of a chore, because it's often hard to know how to set the breakpoints without changing the way your program behaves. There's a Heisenbug effect often that takes place. Do not miss deadlines. Do not get behind in this course. Every semester, mercifully, this is only a handful of people, usually people who are getting ready to graduate, sadly. They decide, oh, I'm going to kind of blow this off. I'm going to miss the deadlines. And then they want to come back at the end and make it all up. It doesn't work. We've had people get very low grades. We've had people fail who shouldn't have been failing. And almost always it's because they just weren't keeping up with the class. So this is an optional class. It's an elective. You don't have to take this class. If you don't feel like you can put the time into it, meet the deadlines, do the work, just drop now. It'll make everybody's life much, much easier. Take a class where people are not as pushy about getting you to work on deadlines. We're going to be using Piazza as the class discussion forum. And I posted something there the other day just as a test. I think I've enrolled everybody here. Please go ahead and try to log in to see if you can access the Piazza forums. And we'll use that, by and large, to communicate. I'll post things like the URLs for the form to fill out. I'll also post other things in response to questions and other things that come up. Something else, this is something I've learned the hard way. When people sit in class on laptops and phones, they aren't paying attention to what we're talking about. And invariably then they come and say, they come to office hours and say, I don't understand what's going on. It's so confusing. It doesn't make any sense. Would you please repeat the whole lecture? So one reason why we record the lectures is so you can go back and watch them. But also, this just is a distraction. So do not use cell phones and laptops in class. I'll remind you a couple of times in the beginning, because I know it's sometimes hard. It's easy to be lured into the distracting world of browsing the web. But do not do this. This will cost you participation points and just means you won't be paying attention. I know it's difficult these days to get unplugged, but you'll have to make the effort here. There's lots of resources available. We've got plenty of office hours. We have 4 graders, all of whom are very experienced. They've either taken the class before or been graders for the class before. They understand the material very well, so they'll be able to help you out. You can go to the website and find out all the information about that. Online forums, slides with lots of links. We'll talk more about that as we go through the slides. All the lectures are recorded, textbooks, lots of things you can use to keep up with this stuff. Please try to resist the urge to email me directly. Use the forum. I'm always happy to hear from you, but it's better if you ask technical questions on the forum, because that way, when I reply, everybody gets the benefit of your question. You can also post anonymously, by the way, if you don't want to know. You don't want people to know what your question was or know that it was you asked the question. Obviously, if you have a confidential matter, I'm happy to hear from you. I have my office hours Monday and Wednesday before class up in the Wondery Atrium, which is kind of a place I like to hang out. It's got a little restaurant up there, and it's very pleasant. So feel free to come by anytime. If you want to schedule other times to meet, I'm happy to meet with you. But in general, if you have a technical question, try to go to the website. Another little point. You probably already figured this out. This is why we have such huge classes in computer science. There are an amazing amount of opportunities these days. Computer science is one of the few fields left where there are more demands for people than there are people to fill those demands. Most other college majors are the other way around. Most majors, there's way more people being graduated with degrees in certain fields, I don't know, classical civilization or whatever, and there just aren't enough jobs for those people. But computer science is not one. So there's a really great opportunity here. This is from a couple years ago, talking about who gets the highest starting salary. For the last several years in the engineering school, and by extension probably at Vanderbilt, computer science graduates have gotten ridiculously high average starting salaries, typically in the 100K plus range. So if you spend time learning this stuff, it will definitely pay off, no questions. And if for some reason something goes wrong, we are obliged to tell you about the evacuation plan. You can go here and find it. The thing to do is walk out the door and go up the stairs and go outside. And if you want to amuse yourself, you could watch this YouTube clip, which is from the movie Airplane. You ever see the movie Airplane, which is a great movie? The stewardess comes in, she says, "I don't want to panic anyone, but does anybody here know how to fly an airplane?" And they all freak out. So that's what we do in the evacuation plan. We all freak out. Okay, so that is the end of the